Okay, so this problem involves a toy car being hoisted to the top of a ramp which brings it down to hit a spring. The object of this problem will be find the distance the spring is compressed. Now we know the spring constant is 24,000 newtons per meter. The height of the ramp is 1 meter. The efficiency of this machine is 80%, or 0.8. The distance you have to pull to hoist this 1 meter is 3 meters, and the force with it which you have to pull to hoist it 1 meter is 2 newtons. So let's start by trying to find the mass of this car through this pulley system. So we can use this efficiency equation, which is work out over work and equals efficiency. And we know that work is force times distance. So if we don't know the force, we can say x newtons out times 1 meter in over 2 newtons out times 3 meters in equals efficiency, or 0.8. Now when you solve this algebraically, you get 4.8 newtons. Now how do we find kilograms from this? We divide it by gravity to get the mass, which is divided by 10 meters per second squared equals 0.48 kilograms. So we know that this car now at the top of the ramp is 0.48 kilograms, so we know its mass, we know gravity, and we know the height, which means we know gravitational potential energy. Now, if we just plug all that in, we get 0.48 kilograms times 10 meters per second squared times 1 meter, and we get 4.8 joules. Now we know the joules of this are going to be the same as the joules of the elastic potential energy at the end because of the conservation of energy. So we know that 4.8 will equal 1/2 kx squared, where k is the spring constant and x is the distance spring compressed. So 4.8 equals 1/2 of 24,000 times x squared. Now if we just solve this, we get x squared to be equal to 0.0004 square root each side. You get x is equal to 0.02 meters, or 2 centimeters. Thank you.